Hi, I'm Ashley with Campbell. Thanks for investing your time to help your community be a great place to live. Before you watch the video, make sure to click the subscribe button so that we can help you make educated decisions as a board member.
Good afternoon, everybody. Like Ashley said, my name is Ben Messerschmidt. I'm with Epic Forensics and Engineering, and thank you all for attending the CEU course. So this should have a fair amount of detail in it, and I'm going to go ahead and just talk a little bit while I share my screen. And this is really going to be focusing just on asphalt pavement. Now, asphalt pavement is going to be the most common pavement material we see down here, mainly in South Florida, but in a lot of the state. All right. Perfect. All right, everybody should be seeing my presentation screen.
Yep,
So
we see
with
it.
that, let's go ahead and get started. So asphalt pavement distresses. This course is really going to be broken up into two sections. We're going to talk about the distresses, why are they formed? We're going to be talking about their physical appearance and a little more detail in them, whether they are going to be caused by loading or any sort of climate-based issue, material-based issue, what have you. But this is really going to be your brief intro into that whole asphalt world. Just a quick background about myself before we get into it. I have had the luxury of evaluating a lot of asphalt pavement in South Florida mainly, but a lot of the state, and it has usually fallen during the summertime. So when it's nice and hot outside, and that's going to be one of the larger stresses that we'll experience, at least within South Florida. Thankfully, down here, we don't have a lot of those massive thermal swings like you see in other parts of the country or the world. So just getting straight to it, this is really going to be broken up, like I said, in per issue. Now here we're going to open up with alligator cracking, and hopefully you all can see my cursor, but if not, I'm really just going to be discussing what we have in the image. So the background image on each slide is going to be showing you what we have going on. So the alligator cracking pattern is going to be very typical and is very straightforward as what is intending to mean. But what this really is going to be just the interconnected fatigue style of cracking. This is going to be load based, meaning that an overloading event would really be the cause, or a structural based issue is really why you're having alligator cracking. Now, from a bigger picture standpoint of things, you're obviously going to be only able to address structural items in a certain manner. And it's going to vary greatly from a more aesthetic based item like weathering, which we'll talk about a little bit further on in this presentation or in this class. So you'll notice these pieces are also going to be less than 2 feet long. There's really going to be small little breaks uniformly connected. The biggest reason why, like I said previously, is going to be load based. The biggest loads you're going to experience are obviously going to be within the wheel path, unless you have some localized distress for whatever reason. If you're going to be on, let's just say, an equipment site and you have asphalt pavement, and if something large was dropped on there for whatever reason during the course of construction, or a staging area potentially for a contractor within an HOA, for example, that could also be a cause of this. Now moving to block cracking. So block cracking, again, pretty straightforward. I mean, these are great names. They're very literal, to say the least. So you'll notice this square style of pattern. And block cracking is going to be climate based, which we're going to get into. But you'll notice that it's going to be very uniform. It's very easy to go ahead and spot to the observer, and also very easy to remember the name. So like I said, climate and durability based. This is also going to be focused on rectangular pieces, and you give that range from 1 foot by 1 foot to 10 by 10. Now we're going to talk about a couple other styles of cracking that might be a little bit bigger, but be mindful of that rough sizing. It's going to give you an idea of why this may be caused and whether or not you have have or don't have items underneath that may be reflecting through. And you see some of the common causes for block cracking is going to be over hardening or shrinkage of that asphalt surface. I mean, so the shrinkage is going to be during the curing process. Now, if that shrinking cycle occurs too rapidly or too slowly, it's obviously going to go ahead and cause some internalized stresses that may present themselves on the actual surface. Same thing goes for a lot of cementitious based materials as well. That curing process is really going to be crucial on the overall performance and at least visual aesthetic to the system.
Hey Ben, the slides
Yeah,
aren't moving, so you're still on alligator cracking is what we're still
no way.
seeing.
All right,
Yeah.
nice. Well, thank you for that. All right, stop share. All right, so it still should be showing alligator. Let me just cycle
Yep.
through. So it's changing.
Yeah, it's changing. Yep, great.
Good. All right. Okay. So let's backtrack real fast. So just the bullet points for the alligator cracking. So fatigue cracking, like I said, pieces are going to be less than 2 feet long. This is the most important thing is going to be it's a structural based issue, and the most common area to be found is going to be within repeated loading areas, wheel path, or if there was a large scale event. Block cracking. So this makes more sense with the actual images. So I'm happy now you all can see it. And again, just with those bullet points here of it being climate based and the overall sizing, the 1 foot by 1 foot up to 10 by 10. And then really the main cause is going to be from over hardening or shrinkage of that asphalt surface. Now, something that occurs at cracks, regardless of what type of crack they are, is going to be pumping. Pumping, as you see in these images here, really going to be that white efflorescence that we'll call it, or the calcification really coming through those cracks. And you tend to see this in areas where water is essentially trapped within the pavement layers. You may have this in new development. You may also have this in an older property as well. But I know this is what I've seen, at least with my experiences. You can even have runoff coming in. Let's say this is going to be within an HOA. You're going to have the roadway at a low point and you have all the homes at high points. So as the water is going to be sloping or sheeting down from the homes down towards the valley gutters, presumably that you would have, there is that potential that as the water is percolating down, that it could entrap itself underneath or within that system. Now, the path of least resistance, if you have some large scale cracks within the pavement surface, is going to be to breathe through the pavement, as opposed to going out through the densely packed earth on the outside. So water, moisture vapor is always going to find the path of least resistance coming up. So water trapped within there. You can also see this stained in different colors as well. So not just white, but if you have any ferric or any iron looking colors coming through here, it may be indicative of the actual organics that you have within the soil, or maybe any fertilizer buildup, what have you. But that coloring would still be indicative of the natural or surrounding soils of the area just evaporating through. And this defect would cause premature failure, as you can imagine. Really, if you're going to be having a structure, which pavement is a structure, now you want a structure to be built on a sound foundation, right? Generally speaking. Now, a sound foundation likely doesn't include water, right? We're not putting a sponge on top of a cup of water or a bathtub, and you're not trying to build a tower on top of that sponge. It's not going to be the best way to do it. Now, building it on the outside on a firm footing, firm ground is really what you want to go ahead and do. So you can imagine over time, really having that presence of moisture or water really within in those pavement layers is only going to cause premature failures within that system. It's not going to live up to its full life expectancy, and you will be having to go ahead and do some large scale repairs if it is left unaddressed. And that could be addressed in a variety of different ways. If it's going to be a water table based issue, or if it's going to be a surface runoff based issue, those are going to be handled in two different ways by your engineer. Now, joint reflection cracking that we have over here. Now, joint reflection looks a lot like block cracking, but you'll notice that these blocks are much larger than that 10 by 10. This is intended to go ahead, and this is what happens when you have asphalt, which is going to be a flexible pavement material on top of previously installed concrete pavement. So concrete, think about it just like a large scale sidewalk. And we don't have too much in South Florida, but you see it in other parts of the country and Northern Florida as well. But there's just be large panels or large tiles, if you want to think about it. And at times we'll see municipalities or whomever go ahead and just put asphalt straight over top. This is going to happen almost every single time, unless you're putting in some separate movement provisions within there. But this is very common to go ahead and occur. And you see this a lot actually on some airfields as well, or redesigned airfields. I'm just thinking about some areas around me, is like even at Boca Raton Airport, for example. They've been leasing out a lot of their land to private companies, and a lot of it was just concrete airfield. Now, in order to go ahead and make it a bit more usable, a bit more allow for more slope for drainage, asphalt was placed on top. If you go out to any one of those properties right now, you're going to go ahead and see joint reflection cracking throughout. So you can see the underlying movement. This is mainly going to be thermal. I mean, the amount of moisture that you get within there should be minimal, but that's not to say that there isn't any sort of moisture. If you have the presence of cracks, the longer that it's there, more moisture will enter into that system. And then you have longitudinal and transverse cracking. So longitudinal and transverse cracking is very straightforward, the same way as every other type of cracking that we've discussed so far. Whether it's going to be longitudinally within I guess running parallel to the actual center line, or perpendicular to the center line, as you see on either side of this image. Again, this is also going to be climate and durability based. It's really just based on visual orientation, and usually at the paving lane joints. So think about it, if you're on a highway or just a 2-lane road, you'll go ahead and you will see that probably towards the center line or towards the actual edge. The causes that you see here could either be from shrinkage, poorly constructed pavement joint, reflection cracking coming through the actual bottom. This is a good image right here to go ahead and discuss the different styles of cracking that we've discussed already. You see the alligator pattern over on that top right. You see a single crack, which is going to be either longitudinal or transverse. And you can also have some branch cracking occurring here. Now, if branch cracking occurs, I mean, as far as classification is concerned, if it's just a branch in itself, that's still going to be considered a longitudinal transverse. But if it's going to be connecting and creating any sort of block, then it's going to be categorized in a different manner. Or again, if this is just following joint reflection, that's going to be the same thing. Okay. Moving towards away from cracking. So this is going to be a depression. So depression, pretty straightforward, is going to be a low area within the pavement. Now, there's going to be localized settlement that may occur, also called bird baths during rain events, and can certainly cause some hydroplaning depending on where it is within the actual area. This is going to be construction or material-based related distress. So whether it's lack of compaction or anything else going on within that system, that is going to be your defect in that spot. It could be small, it could be larger, and even when we get larger in a actual traveling path manner, we're going to be calling that rutting. So you'll see the rule that's placed across or perpendicular to the drive aisle, and you'll see this low area or the shiny area in the middle. This is going to be rutting. As you can imagine, this is going to be a load-based distress. So it's the surface depression within the wheel path, and it's going to be permanent deformation within the pavement layer because of all that consolidation due to the heavy traffic. You can see this a lot even on airfields as well, but municipality roads as well. You can see that on some locations. This is going to need to be a permanent fix. There's no other way to go ahead and handle that. You can't go ahead and seal coat. You can't do anything to that same extent to correct that issue. Raveling. So this is going to be a pretty extreme condition, as at least within this image, as you see it. So you'll see it along the center line. You'll see it along the edge of the drive aisle on either directions as well. Now, this is going to be considered a climate or a durability-based distress. And this is really going to be a medium to a high severity of a weathering condition, right? This is mainly a function of weathering. We're going to discuss weathering briefly afterwards. But you're going to be dislodging the coarse aggregate from the substrate. So you're just creating more available pores and pockets of where water and dirt and moisture can really sit on that system, as opposed to sheeting and moving off. And also a failing of like a surface treatment is also called raveling. It's going to be considered raveling. So when your seal coat goes ahead and meets its end of its useful life, then the pavement surface will really be considered as a raveled surface. Now, moving towards polished aggregate. So polished aggregate, is going to be exactly that. You'll notice within this image, we have a fair amount of openings, loss of aggregate within the area, but the polishing is really just going to be from the overuse of that area over and over and over again. If you were just to go ahead and take any one of these stones, but let's assume it's going to be on a larger scale and really just rub it thousands, millions of times, you're going to create that polishing effect. Now, this will be considered a construction or material-based distress. Again, like I said, it's going to be exposure of the fine and coarse aggregate above the pavement surface. And the repeated events, more polishing is really going to occur in high traffic areas as opposed to low traffic areas. But I'm sure within a pavement system that we all drive on, that we all see every day, you're going to be getting a mix of different issues, even on your drive to work, your drive home, of polished aggregate. You're going to see some weathering. You'll see some cracks in all likelihood, depending on where you live. But these are really handleable, really is the best way to go ahead and put it. But it's important to know what you're dealing with and how to effectively get these things done. This is just, again, that summary of polished aggregate. Moving towards weathering. Weathering is essentially pavement aging, is probably the easiest way to go ahead and classify that. It's also, again, going to be exacerbated by climate or durability. It's going to be a wearing away of the actual asphalt binder, of the asphalt glue, if we want to consider it like that, and really exposing out more of the aggregate, as you see here. This is going to be considered more of a low severity weathering. And remember, if it's going to be a medium or a high weathering, we'd be calling that raveling. Weathering will naturally occur over the lifespan of a pavement system. Generally speaking, from a design standpoint of things, you'd want to have a pavement system or an asphalt pavement system last about 20 years, is really the design focus for it to go ahead and function. So here we have, again, just that quick little summary. And let's look at the distress types of summaries that we have here. So remember, from the load-based issues, really going to be alligator cracking and rutting, which we opened up with. So that can only be addressed in a very specific manner. In all likelihood, you're going to be cutting out that entire section, or repaving that area, and even going down and recompacting your subbase or your subgrade, whatever you may have, but the underlying system before you repave on top. Now, construction or material based is going to be your depression, going to be your polished aggregate. Again, there's going to be different ways to go ahead and take care of those items as well. And your climate durability based issues, your block cracking, your pumping effect, with the moisture coming in underneath, any joint reflection cracking based upon the asphalt pavement that you have over top, longitudinal transverse cracking, your raveling, and your weathering. Now, I opened up this course with talking about thermal stresses. And thankfully, within Florida, we don't have these massive temperature swings, and we also don't salt the roads as well. So you can certainly expect that in a colder, more quote unquote extreme environment, lifespans of flexible pavement like asphalt would be reduced, and the climate impact would be much greater over the course of its lifetime, mainly by way of a lot of like the salting of the roads is going to be way more aggressive than just some of the sea spray that you may get along the coast within either coast of Florida. But that's something important to go ahead and consider. And that's also why different pavement materials are specified in different locations as well. If you're going to be having, let's say, a heavy chlorinated or heavy chemical area, in all likelihood, you're going to want to move towards a more rigid system. So move towards a Portland cement pavement as opposed to just keeping with asphalt pavement. And also the curing aspect of things is going to be very important as well. So I've actually been a part of a few cases from the forensic standpoint of things where even just introduction of hydraulic fluid very shortly thereafter, an area was repaved, just a mill and overlay. So removing about 2 inches and then repaving the area. But within that first few days, trash pickup occurred, what have you, or large packages were delivered, or even just the large trucks from removing and hauling all the material away from landscaping, what have you. You have a massive leak of hydraulic fluid placed on your freshly installed system. That will certainly go ahead and impact that eventual performance. That'll impact its overall lifespan. And it's not going to be to the better. It's going to be chipping away at that. So definitely got to be mindful when you're doing a construction project or anything focused around your pavement. You want to be very mindful of the curing times. You want to be relying upon your contractor to go ahead and make sure that you're allowing for appropriate times, working with any manufacturers to make sure that you're going to be good with that regard as well. And there's plenty of public information on pavement design manuals as far from a municipal level as well as on a large scale DOT level as just light reading for the community. Now moving over into the asphalt repair section. So this is going to be the more interesting part of it. And I mean, in my opinion, there's a lot of different ways to go ahead and handle it. But it can be analyzed in a lot of different ways. And really from those categories that we saw in the beginning or like a bit further on. So distress type can be focused around the load, construction material, or the climate durability. Now, the first one we're going to have is going to be crack sealing. This is going to be pretty straightforward. And I mean, this is a very squiggly based job, and it doesn't, at least on initial glance, it doesn't appear that this was done in the nicest of manners. But as you can see, this is really just going to be an asphaltic based crack sealing that's placed within any cracks. Now, it is important to understand when to use it, how it can be used, and whether or not it's going to be considered a permanent repair or a temporary repair. Permanent repair, this is essentially saying this is going to be your only available repair short of doing a replacement, right? Whether you're going to do a mill and overlay or just cut out a section, anything short of that, that's what we're talking about with a permanent. From a temporary standpoint of things, the expectation is that in very short order, you're going to have those repairs fail. Now, in alligator cracking, for example, the area may extend farther and will actually breach through any sort of seal coat that you have installed there, just because it's a bit more dynamic. And that was a structural based failure with the alligator cracking as opposed to the non-structural items that we have going on the permanent side of things. So it's important to know what available options you have when undertaking or thinking about undertaking a repair project to your pavement. Now, from a planning standpoint of things, this is kind of parallel to this conversation is hopefully being able to identify certain quantities, for example, of repairs and potentially some component of replacement, for lack of a better term, when you go ahead and undertake a project. So let's say within a clubhouse area, you really just have a lot of transverse and longitudinal cracking. But on your main run, you have a fair amount of rutting along your main drag. And those are going to be two entirely different repairs, but getting some quantities for that is going to be crucial for your financial forecast. It's going to be an easy way to go ahead and normalize any sort of construction bids you may be getting back. And that's going to be important because the last thing you really want to go ahead and do is just have a lump sum value from XYZ contractor, pavement contractor. And it's going to be very hard as a board, as a property manager, as an owner's rep, anyone involved within the community to decipher if you have apples, oranges, pears, or bananas. So the more detail, the better whenever possible. It's good also to go ahead and allow for any sort of contingencies on some of the cracking items or the areas that are going to be deemed as a remove and replace, just so you have that. Now, surface treatment. So this is going to be more like seal coating. It's going to be the main way, and you can see that this is really just being rolled on, hand applied on there. Now, this is going to be really a temporary fix only. From a permanent standpoint of things, weathering is really the only quote unquote permanent fix. Now, remember, weathering from those images that we previously showed, it is really just going to be an aging aspect. Now, looking at it from an engineering standpoint of things and trying to consider what's called a PCI number or a pavement condition index, which is basically a 0 to 100 scale grading your pavement. Now, once pavements drop below certain numbers, you can imagine that you have different available repairs, or you might just be forced into replacement at that point in time. But when applying a surface treatment, a crack sealer, and a uniform seal coat, that's going to give you an immediate boost on that immediate PCI number, but understand that it's just seal coating. Seal coating is not going to be lasting a very long time whatsoever. It is mainly aesthetic based. It's just going to be filling in those voids at a higher level, but it's not going to be addressing any sort of structural concerns you may have within your pavement whatsoever. So partial depth patching. So partial depth, you just see just these little shallow patches in these two images within the roadway area. So this can be pretty common if you're just going to be cutting out certain areas. This can be utilized for some shallow raveling or some weathering conditions. This is just going to be in that top section, what we're talking about, not the overall full depth of your slab, not cutting out like you would for, let's say, a new utility run. That may just be a uniform stretch across the roadway or parallel to the roadway, what have you. This is really just talking about that upper layer within even the asphalt, the friction course itself. So you'll notice here how we have it as, from a permanent standpoint of things, from a polished aggregate, this can be pretty similar to weathering and raveling. Those effectively are just slight variations of really the same thing. So that as far as those little cuts that we can take, that's the only real recourse that's recognized that's really going to be worth your while from a permanent standpoint of things. From a temporary, the same thing. Alligator cracking, this is not going to address any sort of structural based concern. With alligator cracking, a depression, depressions are obviously going to, with those bird baths, it's already lower than the bottom of the friction course of the surrounding area. So without a doubt, that's going to need to be a full base cut to address that concern there, and potentially even some more subsurface work. And then rutting again. So obviously not going to go ahead and fix that scenario, what we have. So then we go over to full depth patching. So from a full depth patching standpoint of things, this is pretty permanent, as I'm sure we can all imagine. This is going to be, just from the patching standpoint of things, these are going to be localized areas. You're going to be looking at full depth patching for mainly your structural components. And if your cracks start to get too bad, so to speak, if your PCI number starts dropping too low, full depth patching is going to be considered and probably likely the only option at that point in time. Now, patching versus going ahead and completely redoing and just doing like a mill and overlay with some structural based repairs along the way, those are really going to be your two options likely at that point in time. Mill and overlay, just so everyone's aware, I mean, essentially you're just going to be having large scale machines just chewing up the actual roadway surface, usually about a depth about 2 inches. And they're going to be chewing that roadway surface up and really just applying a brand new asphalt coat on top of that. That is obviously going to give you a brand new 100 PCI number. So regardless of whether you're 20, 30, 50, 90 before, you're going to be all the way back up at that 100 value. But from a full depth patching, if there's going ahead and you need to put in a storm drain, for example, or a drainage structure, utility, anything along those lines, or if you have some localized settlement on the edges, on the end of the crowns, or in the swales, you're going to be going ahead and cutting that section out, doing a full depth patch. So you see here, from the permanent standpoint of things, we have the alligator cracking, the block, compression, joint reflection cracking, longitudinal transverse, and rutting. Now, and from a temporary standpoint of things, full depth patching certainly is nothing temporary is about it. You're going to be impacting the pavement structure itself, not just the actual friction course, that top section. So that's what we have over there. And it seems as though that I've flown through this presentation. So with that being said, I'd love the opportunity to go ahead and discuss these question and answers. We do have a fair amount over here, so I'm going to be answering these on the fly right now. So if everybody has, I don't know if everyone has access to it, but I'll just read off the question and I will discuss the actual answer. Let me do is stop the screen share right now, and let me just read from this. So we have Carl Silverman, excuse me. So it's gonna be a multi-question. When seal coating older pavement, which is best for the most durable coat, coal tar or asphalt? You have 2 sprayed cost, I'm assuming that's coats, 1 brushed, plus 1 sprayed, or 2 brushed, and the hours between coats, the days to cure, any advice about hot crack filling, and anything else we should specify for best results. We want to go ahead and extend the life of their current pavement, given financial constraints, as opposed to doing a full removal and replacement. Okay, so coal tar, what's going to be the most durable coat? I'm a big fan of actually rolling on or brushing on the coating system as opposed to just spraying it. Spraying it, I mean, think about doing anything outside and attempting to spray paint even your house or any structure in the wintertime in at least Florida, it's going to be the windy time. Spray is going to be very dependent on the operations and how well or how poor the installer is. Brushing, on the other hand, can't really mess it up that much. Brushing, you're actually going to be walking that and pushing that roller along that full length of the actual roadway surface. Coal tar versus asphalt, I mean, you're going to be splitting hairs a little bit. I mean, ultimately, I would strongly just rely upon whichever you can better brush. Something that's going to be less viscous is going to be wanting to permeate deeper into the actual pavement structure. So that would be my recommendation. And I'm sure there's going to be separate manufacturers out there that are going to talk about viscosity rate and actual permeability coming through. Hours between the coats are all going to be specified during within the manufacturer literature, and the days to cure as well. Advice about hot crack filling. So this is essentially going to be the seal crack, or the crack sealing that we were talking about. So It being hot is essentially you just having a kettle on site to go ahead and pour it in hot to get that to permeate further down. Again, it's going to be less viscous. It's going to be able to actually better coat the area. A hot application versus a cold application, generally speaking, is going to be a preferred route as far as overall performance when you're dealing with anything asphaltic or bitumen based. You want to have that heat is really going to be to your benefit. It takes a lot of the thought out of the process, and you're less reliant on the applicator, and you're relying more upon the just the material itself. So you're reducing your variables in the system, which is always going to be a step in the right direction, just given historical construction-based issues. Anything else to specify for best results? It all depends on your financial constraints, but I mean, if you have any localized structural issues, I would strongly recommend addressing those. If you're cutting out certain sections, I mean, it still shouldn't be all that expensive to address, but any low spots, any voids, anything from a surface standpoint of things, or surface preparation standpoint of things, should certainly be taken care of well before you're going to go ahead and brush on a seal coat on your entirety. If not, then you can expect those bird baths to fail as like not the next day, but certainly the first location to go ahead and fail. Okay, so Peter Reinhardt, at what point do you resurface versus patching? So resurface versus patching is really going to be looking at overall extent. So a survey, I would recommend a survey be done of your pavement, whether it be by an engineer or even by an actual contractor, if you have faith within a specific vendor, to go ahead and identify what sort of conditions you have. And now that everybody is an expert in identifying asphalt pavement distresses, you can go ahead and identify what is going to be really a structural based repair and what is going to be a more aesthetic based repair. Now, it may make sense financially to go ahead and simplify the system even further and just say, okay, well, about 50, we have roughly a 50-50 breakdown of areas that have structural conditions versus quote unquote aesthetic conditions, and coupled with the fact that this pavement is 25 years old, for example, the age is obviously going to be a big component too. You're likely going to be looking towards actual full resurfacing, mill and overlay with some associated structural repairs. But if we're talking about these conditions that may have popped up at year 10, for example, maybe patching some of the areas that see the most traffic, whether that be pedestrian or vehicular, those be prioritized first, then come in and actually do an actual full mill and overlay. These projects, as you can imagine, if you're going to be doing it throughout the entire community or entire sections of road, they're going to be costly. They're going to take a lot of time. There's going to be a traffic impact, if nothing else, for the surrounding people, the surrounding tenants, the surrounding owners, the surrounding humans in the environment. So you want to make sure this is going to be planned out appropriately. There's also going to be associated MOT involved to make sure that all the traffic details and traffic constraints are going to be followed by that contractor, but that's going to be the burden of the contractor as opposed to anyone from the owner. All right, so L. Culp, to prevent rapid drying, should we in South Florida not repave, recoat in the hotter months? That's a good question. So for that, typically in that scenario, I would rely upon the manufacturer's recommendations. Number one, they should have a technical specification on there talking about the maximum temperature to be installing any new asphalt. Is it preferred not to do it in the hotter months? I mean, generally, yeah, but at the end of the day, if work needs to be performed, the heat shouldn't be the reason why you're not doing the actual project if your concerns are that great. Like I opened up this presentation with, thankfully our temperature swings in South Florida aren't huge, even though being outside in August or September and middle of the day is brutal. It's still not a 40-degree temperature swing. Now, paving, I would suggest, I mean, if paving can go ahead and take place overnight, if it could take place in the early morning, figure out those operations with the contractor that's selected, that's going to be preferred, that's going to increase the amount of available curing time, that's not going to be impacted by the surrounding environment all that much, right? If you're going to be pouring concrete or even doing your asphalt before the sun comes up, it's going to have a longer opportunity to actually cure as it wants to, or consider a controlled environment, so to speak. Dan Gleason, what can be done to reinforce the turning points in parking lots around the medians? The dumpster trucks just tear up the asphalt around the ends of the medians. Okay. So if this is going to be focused on the asphalt leading up to the medians, and presumably those are just going to be your concrete medians, I mean, those should be essentially a crown if it's going to be in the median. So you're going to have the highest elevation, and then coming down, if it's going to be a center crown. Part of that design may have a little more asphalt, a little more friction course within there to go ahead and give you a bit more meat, but it depends on how bad these are getting chewed up, number one. I mean, you can even go ahead and extend out that section of median if you want to go ahead and provide a little more protection. You may just be pushing the condition farther out. But as far as what can you do, I mean, slow speed turns are really going to be the biggest factor to pavement performance on let's say within a residential community. If you were to go ahead and be in your car, let's just say you're in the dump truck and you're not moving at all, and you just take the steering wheel and just go back and forth, back and forth, back and forth. I mean, yeah, that's a massive load on that system, massive distress. You're just shearing the actual aggregate on that surface. So there's not much you can go ahead and do to prevent that within that scenario. Just understand those are going to be the areas that might need patching first before everywhere else. But the slow speed turns, not the high speed turns, but slow speed turns are really going to be the area to focus on. Sean Eubanks. So percolating is okay in an HOA. Don't know if I understand the question, but so permeating into that actual pavement surface, if you're going to be utilizing a seal coat, you're going to want to have some level of penetration. Now, the most important thing, as I previously stated, is going to be that surface treatment first. So if you have any cracks that need to be addressed, those get addressed first, or an additional detail coat goes in there so that you can have a uniform or attempt to have a uniform finish on top of that system. Oh, okay. So if not answer, what prevents pumping from showing up? Okay, so pumping's a unique scenario. From an engineering standpoint of things, it's a fun scenario to go ahead and figure out. Certainly not a fun scenario to go ahead and live with, but how can you prevent it? There's a lot of different things to prevent that from occurring, but the first thing to figure out is, why is it occurring at your property? So in this scenario, you don't want to go ahead and treat the effects. It'd be money better spent to figure out the cause, treat the cause if at all possible. Now, if that cause is just going to be that your pavement was installed 2 feet lower than it should have been, and the water table is a couple inches below your final top lift, it's kind of hard to fix, other than going ahead and elevating everything back up to where it likely should have been. Now, if it's going to be the runoff scenario, though, that I alluded to previously in this presentation, you can go ahead and install some subsurface drainage. So if you have valley gutters on either side, you're going to have concrete valley gutters. You can basically put in a French drain, or a subsurface French drain, that's going to absorb any of the water below the surface before it actually gets underneath the pavement, and then have that piped to your nearest drainage structure, or doing some work to the actual soil itself, maybe creating a more free-flowing medium like with 57 stone or any sort of drainage rock surrounding that area to really allow more water to make it to that point so you can move it away. That's really going to be the focus. We have, all right, so this is going to be Kevin Johnson. We have a concrete crack between the slabs and the wall in the gym, and water comes through when it's raining. Do you intend to fix this? Do I intend to fix this type of crack? So it depends on what the slab is made out of. So this is going to be slab wall in the gym. So this is, if your asphalt pavement butts up to your building structure, it all depends on where the water is actually coming in. If you have a void between your horizontal surface and your vertical surface, an easy low-hanging fruit is to go ahead and take care of that interaction. But this appears in the 3 lines of the question. I would suggest first looking at the actual building structure itself, and then working your way down, depending on where it's presenting itself. You do have cementitious material in all likelihood on the outside of that building by way of stucco and paint, and any sort of sealants around any openings. So I'd focus there first. You can also go ahead and do a reconnaissance moisture test to determine where that's coming in from. Edward Short, do I consider this raveling? I don't see a photo, so no. All right, William Pecker or Pekar. What about global warming thermal stresses in Florida? A good question. It's a very good theoretical question. Between global warming in Florida. Now, remember, the lifespan of pavement from a design standpoint of things is intended to be about 20 years. I mean, global warming is obviously going at a variable rate. Hopefully it doesn't get worse for everyone's benefit. But will that have an impact? Certainly it will. I mean, it's not going to be towards the better, but it's just going to be not a known condition, but a condition to be taken into account during the design as well as the construction of your new asphalt or just maintaining your asphalt. So it may increase the frequency of any sort of repairs that may need to be performed, just the same way as if you were living up in Michigan, northern Michigan, to go ahead and deal with the salt and the temperature variations you have there. Okay. Tatiana Hakim, how would you clean this hydraulic stains or the oil stains from the asphalt? Okay, so how would you pull those components out? That's a very good question. That's a little bit tough to do. So given the fact that it's going to still be, have some level of petroleum in there, right? It's still going to be pretty oily. You're going to attempt to try to pull some releasers to get that off that area. But depending on how long it's been sitting there, there might not be much you can go ahead and do. Even hitting with a pressure washer, you're just going to be removing the actual aggregates. I'd really be focusing on that area or the areas in question, see how, number one, see where they are, see how bad they may be performing from a pavement structure as opposed to just an aesthetics. That would be my first area to focus on. If it's degrading at a rapid rate, then you might just have to be just patching that specific area. If it's going to be a slower standpoint of things, then something you just keep an eye on. But one thing I do want to go ahead and make mention with that example that I gave previously is that you're not going to expect this to be quote unquote catastrophic failure, right? That this is going to be still a pavement surface. You still have, should have solid structural layers beneath the friction course that will support that system. So yes, you may get the friction course will degrade, absolutely, but it won't be a day one you have the oil stains, day two it just totally caves in. That's not going to happen. Got plenty of questions on here. There's no way I'm going to get to all these. I'm going to move a little bit faster. Okay, Courtney, we have some buckling from roots in our asphalt. Look like they're needing attention, but we're concerned that if we start patching, it'll weaken the integrity. you have an opinion on the domino effect once you start cutting into a section. So for this scenario, for any root intrusion, let's just say for live oaks, which there are plenty that designers like to go ahead and put right next to roadways, that you'd go ahead and just cut out certain sections and start patching. Now, will it impact the overall performance? Not all that much. At the end of the day, you're talking about the intrusion from the edges coming in. So the amount of actual traffic and loading you're putting on those edges, whether they be this wide or this wide, is going to be relatively minimal. If it's going to be within a community as well, you're really just talking about some low speed areas, maybe immediately adjacent to a parking space, for example. So I wouldn't be overly concerned with that. Just make sure that when you do go ahead and perform that work, I mean, you're cutting that root system to make sure you're not having to do that immediately afterwards, the same exact approach. Christopher, we're subject to coastal flooding. Are there certain materials mixes or asphalt construction repair techniques that survive floodwaters and saltwater immersion better than others? That is a great question. So with respect to coastal flooding, I mean, obviously the immersion is not going to be helping out anyone, which is the unfortunate part of it. Now, and that wetting and drying effect will certainly reduce its lifespan. That's the unfortunate. Now, certain materials or mixes, if possible, I don't know what sort of sections we're talking about here. I mean, if there's any way, if there's some small areas or around some utilities, you can go ahead and at least at a minimum have some concrete collars, or even extend a pad farther out. So you are making sure those embedded utilities are going to be taken care of and not really move all that much. That's going to be a step in the right direction. Now, materials and mixes, there's certainly going to go ahead and be admixtures that could be put within the actual systems to extend or have a rapid cure or high strength, just like you typically would have for anything concrete related. This would be honestly best really dealt with the actual manufacturers, because these are going to be worldwide companies that do this everywhere, and they're going to have a product line that could certainly help and assist. And I'd even be focusing on actual warranty information for that same item as well. Peter, is seal coating the same as rejuvenation? Yes, it is, generally speaking. Seal coating is essentially that. You're just attempting to beautify that system. It is really a short-term option, but you should be able to get away with that depending on what issues you have. Or at least seal coating once on a pavement system, and then just reevaluating, see how that performs and how long that lasts. Sue, how long after initial road application should sealant be applied? It's going to vary on every single property. It depends on how fast and what sort of issues you actually have coming through. If things are going to be coming through right away, you're more than welcome to go ahead and address that then. Cracks are only going to progressively get worse and progressively get wider, just because it's going to be a cavity for moisture to get into. So a hairline crack today, years from now, will certainly be a much wider crack on your pavement surface. How long should a good seal coating last? That's going to go ahead and vary, as you can imagine. At a minimum, you should be getting a singular year out of it, but at a maximum, you'll definitely get a few years. Even going up, I would say maybe potentially 5 years, depending on how thick you go. But with doing that, see what sort of warranties are available manufacturer, but more importantly, labor-wise with the contractor utilizing. Steven, go ahead and answer about one or two more on here. I'm just going to fly through some of these, try to find a new one. Really fast, the PCI index from good to bad, 100 is going to be good, 0 is going to be bad. Milling and overlay from Patrick. No, we didn't speak, or milling and resurface. We didn't speak very much about that in this course. That's really more of a replacement as opposed to an overall repair. But milling and overlaying is really what you're going to see, like I stated previously, on any large scale, where they have a massive equipment to go ahead and remove the first few inches of that system and reinstall a new one. Grab one more. Okay, Joseph. So subbase, soil, broken irrigation, or waterline breaks, leaks, can they contribute to depressions or causing distress? Absolutely. Anything subsurface like that, there's a lot that can be going on subsurface that we honestly just can't see. Now, it's what you can happen if it's going to be localized immediately overnight. I mean, obviously, the potential of a sinkhole is very rare, but depending on where you are, that could be an option as well. There are a lot of even testing companies out there, like a geotechnical lab, that can really use ground penetrating radar to determine whether or not you have voids, if nothing else, or even going through and finding a utility tracing company or a locator to see what you have underneath to even determine that. I mean, also as more of a reactionary step, if there's going to be any sort of water break, I mean, hopefully you're not waiting a month to go ahead and see that your bill is going to be in the thousands of dollars for that water that month. But that's also another opportunity to go ahead and see what's going on, at least initially. But if something just immediately pops up and it starts like expanding, I mean, this is just like if you were to find something strange in your body and immediately start expanding, you should probably get it looked at. Generally speaking, and the sooner the better to go ahead and minimize any potential damages that you may have within that system. Okay. This is one I get a lot. So from Matthew, is rejuvenation worthwhile or a waste of time and money? That's certainly going to vary across each community and how large of a space you're really talking about. If you're mainly dealing with weathering, some low raveling or minimal raveling, to address just weathering, sure, you can go ahead and put on a seal coat. That'll surely meet the aesthetic aspect of things and give you some performance benefit, at least in the short term. Now, seal coating is certainly a temporary measure. I don't want to go ahead and rely upon that and say it's the end all be all, because it certainly isn't. And for the contractors in the industry are going to be going ahead and stating that same exact thing. Milling and overlay will be the other extreme as well, but localized patching would be the next step in that system. But is it worthwhile? More times than not, I think it is worthwhile if especially the associated costs are in order. Okay. I apologize, I didn't get to all these questions here, but I see we're butting up to the hour. I'm going to do my best to go ahead and try to get you all answers to these questions. Hopefully, I saw a lot of repeats on here, so hopefully I answered these questions or in an overwhelming majority for you all. But thank you very much for your time. I hope this was beneficial. And even though we had a little bit of a short presentation, I'm happy that we had a long question and answer session. So thank you for your time. And Ashley, thank you very much as well.
Awesome. Yeah, thanks for doing the presentation. It was great. I did go ahead and launch that poll a little while ago. So if you haven't had a chance, please go ahead and take the poll to give us your feedback on how we did today. As mentioned before, I will be emailing out the presentation, a link to the video recording of the webinar. I will email Ben's contact information and information on our future classes. And then I will be sending the attendee list over to Epic so that they can get you guys your credits. Thank you everyone for joining us, and we will see you next time. Thanks again, Ben.
Thank you. Take care.
Thanks for watching. For more great educational content, click the subscribe button now.